Hi guys, welcome to Simple Math. Today I will solve some exercises of simplifying roots. Yes, here we have three exercises and I will explain how to simplify each radical or root in each case. To simplify radicals, guys, we use prime factorization, right? We use prime factorization. All the exercises we have here are roots that have the index the number 2. So that's why we call square root. Now we use prime factorization to simplify. So it means we take the 50 and then we do the prime factorization. So as you know, 50 is divisible by 2. The answer is 25. 25 is divisible by 5. 25 divided by 5. 5 divided by 5, 1. Everybody knows this. So this is the same that 5 squared. As you know, we can take out, yes, because 50 must be the same than 2. Remember, we multiply everything. 2 times 5 squared. So because there is a property, we can take the 5 out and 2 stays inside the root. So the final answer is going to be 5 goes out is 5 square root of 2. These 2, because this one doesn't have an exponent 2. So, and this is the answer or the simplest form of this root. Let's go to 120, we apply the same strategy. We do the prime factorization. So 130 divided by 2 is 60. 60 divided by 2 is 30. 30 divided by 2 is 15. 15 is divisible by 3. So 15 divided by 3 is 5. 5 divided by 5 is 1. Okay, this is the same. We make group of 2. Why? Because remember the index is 2. So we have to make groups of 2. So this is 2 squared, and that's it. We cannot join these like 3 numbers that we have here, right? So a square root of 120 is the same than 2 squared times 2 times 3 times 5. All right, so we take this number out. So we have 2 square root of 30. Yes, 2 times 3, 6 times 5, 30. This is the answer in this case. All right, so let's try with another one, and then if it's possible, I explain another one for you, a part of this one. So to solve this exercise, we are going to use a root property that says that when we have a root, yes, or a radical, and inside we had a fraction, yes, so we can say that this is equivalent to have the square root of 8 over the square root of b. Yes, these two expressions are equivalent. So I'm going to use that property to explain or to solve this exercise. All right, I'm gonna take my eraser. I have it very far from the camera. Let's do it. Okay, don't forget about that property. So we have a root, we have inside a fraction, so we will apply the property that says this is equal to the square root of 81a4 b6 y3 over the square root of 25c2. So I'm going to work out with this exercise, and then I'm going to work out with this exercise. First, solve this one. All right, so I'm going to solve it here. What happened with 81? The square root of 81 is 9, so we can take that out. Yes, so 9 is the square root of 81. The square root of a exponent 4, yes, square root is a exponent 2. Yes, a exponent 2. The square root of b exponent 6, is b exponent 3, or b cubed. Yes, and y3 doesn't have square root, so it stills inside the root, like this. All right? So, we can do the same thing here, 25. What is the square root? This is equal, right? What is the square root of 25? 5, and the square root of c square is c. Yes, as a conclusion, we can like play with square roots, right? Okie dokie. And then here in this part of the exercise, we see we can simplify things because look, there are invisible multiplication signs. In this case, we cannot simplify anything here, but just imagine the answer is not this. Let's imagine it has another letter. For example, A2 here. Just an example, right? This is not for real. If this is the case, we can cancel this one and this one. I mean, we can still simplify things, right? So like this, all right? Okay, guys, remember this is not for real. I don't want you to think this is the final answer of the exercise. This is just one example for you, for me to show you that we can still simplify things in case we need. All right, guys, thanks for watching Simple Math and see you in the next video. Bye-bye.